Okay, so here we are looking at example 3 for 9-3 Math 7. So the next part of the notes talks about complex volume problems. Just like in previous lessons, Unit 7, we talked about complex areas. So naturally, as you're taking a look at this figure, you might be noticing that there are multiple shapes. So again, multiple shapes means multiple formulas. There are two shapes, you need to be using two volume formulas. And those formulas will differ depending on the shapes that you're dealing with. Because you're going to be using multiple formulas, it's important that you remember to add to get the total volume. Right? Because you're going to find the two parts and then you're going to add them together to get the total. Add to get the total. Okay, so like we practiced day 1, the most important thing is identifying the shape correctly. You can't get the right formula if you don't know what the shape is. And again, I'm just going to organize my work here. So I've got a top shape, and I can see that that top shape is a triangular prism because it has a triangle in it. And I am looking up in my notes or, going back and recognizing that the triangular prism formula is that 0.5 base times height times height. So volume equals 0.5 base times height times that second height. My bottom shape is a rectangular prism. Boom. Going back to our notes and looking at the formula for a rectangular prism or a cube, and that is my length times width times height that you guys are most familiar with. Times height. Okay, so I find it helpful to kind of highlight the shape that I'm looking at as I'm doing it. That kind of just makes it a little bit easier for me to visualize things. I'm a visual person. So volume equals length. The length of that bottom box is an 8. My width is 6, and I have a height of 5. And again, those can be in any order. That's not necessarily the length with the height organized. You might have it flipped around, and that is totally okay. 6 times 5 is 30. 30 times 8. 8 times 3 is 24 with an extra 0. So 240 centimeters cubed. Now, your triangular prism can get a little bit more complicated depending on, the way you look at it. All right, so filling in pieces for our triangular prism. The 0.5 stays the same. My base, this is talking about the base of my triangular prism, is right here. That's the base of my triangle, which is 8 because we know rectangles have opposite sides that are equal. Now, this first h is the height of my triangle. The height of that triangle is how tall it is from the top vertex straight down, making that 90-degree angle. There's nothing inside of the shape that tells us, but we do know that right here, they're telling us that this is actually 4 centimeters. So that height of my triangle is actually 4. The second height, being the prism height, this one you might need to go back to your notes because remember, that triangular prism is not supposed to be sitting on its rectangle. It's supposed to be positioned so it's sitting on the triangles. The triangles, when it sits on the triangles, you measure how tall it is right there. But notice in our diagram here, they have this rotated. See how this is the height and then they're rotating it. The height is still over here. The height of this triangular prism is actually 5 centimeters. That 5 coming from down here, which is also the same as this right here, that 5 is my prism height. Okay, now we can mathematic that. Write into your calculator 0.5 times 8 times 4 times 5 gives you 80 centimeters cubed. Don't forget to remember to add the total volume to get your 80 plus 240 equals 320 centimeters cubed for your total volume. The hardest part about that is going to be making sure you understand the difference between that prism height and that triangle height.